3 shortcuts. Guess it was next page. I guess it was this page. We had done one of the shortcuts, side, side, side. And on that side, 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 they had given us information about 3 things. Nothing about the angles. It was just knowing that 3 of the sides were congruent, right? 3 of the sides were marked the same. So you had gone through, marked up those 3 sides congruent here and there, marked it into the patty paper, you transformed it, it landed on top of one another, and we said, okay, we don't need to necessarily know that the angle is congruent. If the sides were congruent, we were good to go, right? So that was one of our shortcuts. All right, we did that. Then to the next page we went, we ran into another shortcut, almost. When we did this on Friday, we did the same thing. We did what we called side angle side congruence. Now, when we did side angle side congruence, we did this, and I had to do that, and then what we found out was there is a typo.
Yeah.
Thank you. There is a typo on your book. All right, thank you, sir. There's a typo in your book. When you guys did the patty paper and you transformed it, this triangle did not land on top of the other one. It was a different shape, not a different shape, it was different size. And I said, hold on, I promise you that it is one of the shortcuts in side angle side. It does work, okay? So you can still believe me or not, you can Google it, but side angle side, that triangle should be the exact same shape, exact same size as the other one. And then again, I promise you, side angle side is one of our shortcuts. So right now in triangle congruence, we have, Jillian, can you slide me down that marker?
No.
Thank you, Jillian. We assumed it went the whole way, right?
Yep.
All right. So we have so far 2 shortcuts, side, 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 where we need to know something like, 3 pairs of sides, and the other one was so far side angle side. Now, in that side angle side, all right, we've got what? One side and another side, right? Now, when we've got that going, the angle though matters. And the one thing I don't necessarily like about the example they did with us is you didn't mark the picture. Because where that angle is at, it does matter. The angle, as you read SAS, the angle has to be between the 2 sides. So if I was to say mark this angle as congruent, okay, is this read as side angle side? Is this angle between the 2 sides that are marked? No, because here is a side I have not marked, right? So this is not read as side angle side. So when I go back here, here's my 2 sides. What's the angle between those 2 sides? It's got to be that angle right there. Okay, so when we just start rattling things off, you got to make sure you're paying attention to where those markings are at. And then right at the end of the period, we had a few extra minutes. We got to the last one there. And the last one was something we call angle side angle. I think we did the last one, right?
Mm-hmm.
Okay. And we ran into a third shortcut, which we call ASA. And I keep bringing that same triangle up, so why not? And the same thing means the same thing on this one here. With angle side angle, we have 2 angles known. All right, wherever you want, I want to put these 2 angles. I don't care. But now, where I mark that side congruent, it does matter. Is that between the 2 sides? Oh, sorry, is that between the 2 angles? No. So that means something totally different. That is the side that's between 2 angles, right? So that is read as angle side angle. So you got to pay attention to where things are located to know what shortcut we're talking about. Okay. Now, before I go back to your book here, there's 2 additional ones that are not talked until later in your book. I don't like that. So what I'm going to do is move those sooner than later by throwing out this page, and then we're going to go right back to your book here in just a second. So I'll pass this out to you. We're going to do the 2 additional ones. We're going to have 5 shortcuts here, and then we'll go right back to your shortcut. Okay. those books just yet. All right. And come right back to those books. Okay. What we have here is two more. The two more are not talked until later on in your book. And what I would like you to do then is take a look there on that first question there, that first example, A and B. And on A and B, oh, thank you. On A and B, there's two other triangle congruences. And what I like you to really quick do is, like we've been doing, take your patty paper on those two triangle congruences and go ahead and put triangle LKM with the markings. Put it on your patty paper. You do something with that patty paper so that it transforms and lands on top of the other triangle. And then go do that for the other triangle on the other pair, ACB. Some way, somehow, can you make it land onto the other triangle? Prove that those congruences are working. You might have to do whatever you need to do. And as you do that, I'm going to bring up my set of notes here that goes along with that little insert. Okay. Get over yourself, Eva. I'm sorry. SU? Yeah. Now pay attention to the markings because I know when they start to rotate and flip on you, students don't necessarily pay attention to the right areas. Yeah, K and M, pay attention to those markings. It's definitely going to U and S. All right, not to T and U. K and U have 1 and 2 markings, 1 and 2 markings. Just pay attention that it is going to U and S or yet S and U. That's fine, but please don't bring in that T with it, right? That's one pair, and then what's the last pair? L and M was the other one, right? We haven't talked about L and M yet. That was not stated to us. And what's L and M going to? Side LM goes to what? TU, right? Nope, sorry. What is it? LM? Yeah. Is that a screw up?
The tick marks are screwed up.
The tick marks are screwed up, aren't they?
I think so.
Yeah, the tick marks are screwed up. How's that going?
Yeah.
Yep, the tick marks are screwed up because this tick mark should be here, isn't it? So that tick mark, I need to fix that for a second there. So that tick mark should be here. So LM should be going to what? TS. Thank you on that. So LM should be going to TS, we just said. And that KL should technically be like right there. So imagine this was not there, blank, okay? Now, on that congruent statement, that triangle congruent statement is naming the two triangles. So naming that first triangle, somebody, how do you want to name that first triangle? Name it, not Bob, but KLM, I don't care. Now, however you name that first one, I don't care. But now that you've locked in the first one, okay, determines the second one. K goes with what? U. Okay, U, and then M goes with S, I heard, and L goes with T. Do pay attention to small details, all right? All right. You checked the last one there. The last one you said yes or did not work. Yes or no? It did appear to match up, right? Now on that last one, what's the other thing that jumps out to you on letter B? About this triangle maybe compared to the other ones we did. It's our first kind of real right triangle. The other ones could definitely be right triangles, but this one for sure absolutely has to be a right triangle. Because in the name of this one too, what also pops out to you maybe on that one? Yeah, the word hypotenuse. So on our last one, we call it HL. And the HL for the hypotenuse, for sure, the only way this one works is if you got a hypotenuse happening, sorry, a right triangle happening. So this one has to be happening as the if it's a right triangle. I keep saying hypotenuse. So it's got to be in a right triangle. And you got to have a hypotenuse marked and one of the legs marked, okay? So hypotenuse legs got to be a right triangle, hypotenuse, and a leg. So there's three things happening in there. First thing is right triangle, and then the hypotenuse and the leg. All the other four shortcuts have three things happening: a side, an angle, and a side. Side and an angle, and then one of the other combinations. So we can see three things happening. This one looks like there's only two things happening, but really the third thing is it's got to be a right triangle. Okay? So those are our five shortcuts. And then kind of the same thing there. For our time here today, I'm not going to worry about it, but let's go ahead and write the triangle congruence. We won't mark up what else is happening. But on our triangle congruence, one more time, name me that first triangle. I would go with ABC as well. Probably go with maybe that Captain Obvious there. But then as you name that first one, it determines the name of the second one. A goes with what? A goes with X, and B goes with what? And C goes with, okay? So that's what we want to use, is try to determine then, can we show triangles congruent? Not by getting out our rulers and our protractors and measuring. That's not what we're doing. We want to look to see if we have enough information and match up to one of those five shortcuts, because mathematicians are lazy. We want to see if we can match up to one of those five. So let's do a little practice kind of here together before we go kind of back then, okay? So looking across here on this first one, keeping that again in mind, can we match this up to one of our five shortcuts? All right. All right. So we look at that first one, or kind of, we call this one of our bow ties picture. It looks like a bow tie, right? Anybody get an idea maybe of what of our shortcuts we're maybe aiming to use here? Take a second look at that. What are those shortcuts maybe you think we might be able to use here? Eva.
SAS.
Okay, I see two sides, right? I see a side, I see a side, and I see another pair of sides. I don't see the angle though. Where's the angle coming in at?
The vertical angles.
Thank you. So when you see the bow tie picture, vertical angles, don't forget about the stuff that we've been working on over the last couple of weeks now, okay? Vertical angles are definitely hiding there. They're not marked. They don't need to be marked, do they? Because what do we know about vertical angles? They are always congruent. So vertical angles, sometimes they're marked, but most of the time, they're not going to be. So that is your responsibility to realize, hey, vertical angles are congruent. Mark them up, all right, and then we're playing that matching game. Can we go through and read through and see some type of combination there that matches up with that? And that angle is between those two sides, and yep, I would agree, a side angle side is what's working here. Could you take that patty paper, trace on those markings, somehow transform it so it lands on that one, those markings land on top of one another? And it definitely does, doesn't it? Doesn't it kind of rotate about that point, C, and it lands on top of one another? Side angle side is working. The congruent statement is triangle, name me one of those. Okay, A, B, C. We locked in one. Now, A goes to what? E. So again, if you need to take that patty paper, that's your buddy. And I mark the way for this to land on top of one another, I got to rotate this around so that A is coming along and landing on E, and B is landing on, yep, D, and C is on
C.
Okay, that's all I need from you. playing the matching game of what of those 5 could possibly do for us. Okay, here's another new one today. What do we got here going? What do we got marked up so far? 2 angles, right? So of our shortcuts here, which of the 2 do you think we're aiming to use? AAS or ASA? That makes sense, right? I don't have enough information here, probably not enough information here. Sure as heck does not look like the right triangle, does it? So the question is, where am I getting that side at? Where's that additional side coming into play at? Eva?
In between the 2 angles because they're sharing it.
Okay, she says they're sharing it. I see 2 I see 2 triangles here, don't I? We clearly see there's 2 triangles here. So let's think back through stuff that we've done throughout this year already, like Pythagorean theorem I'm thinking about. We've seen where we've had to do some work with Pythagorean theorem where we've had 2 triangles that are sharing the side, right? And when we split these up, we're sharing that same side. And that's exactly what's happening here. If we were to trace out one of these triangles, we're going to see that this side MT is in this triangle, and isn't it also in this triangle? So what we're going to do is mark that. That's how we mark that. We mark that as a single tick mark, and it shows us that's in both of these triangles. Now, in geometry, what we call that is the use of, now I don't know how much you remember way back when to some of the properties you guys have talked about back into like 3rd and 4th grade. 4th grade is really when that starts happening. It's something called the reflexive property. It's when you guys start talking about maybe like the associative property, commutative property, those areas. All right, that's when you guys start learning about some of those properties. But that's the reflexive property. The reflexive property is being used here. MT is equal to MT is equal to itself. Okay, is congruent to itself. That's the reflexive property. So here, what we have here is, again, if we took our patty paper and as we trace in MHT, angle, side, and this double angle, and we rotated it, it's going to rotate, it's going to land exactly on itself. And then after that, it's going to be matched up with angle, side, angle. This thing is working by ASA. That angle, side is between those 2 angles, and then we're able to use that particular shortcut. Okay. So we hadn't talked about any of that yet until like right now. And then we can name it out. Triangle, what? However you want to name that first one, I don't care. Pick a combination for that first triangle. MHT. And because we stated MHT, that set the tone. M goes to what? T. So M is the single marking, T is that. H is no markings, so that goes with A. And MHT, T is the double, and what's the double in the other one? M, correct. Okay. All right, let's keep rock and rolling here. On letter C, what jumps out to you on letter C? What do we have marked up? A bunch of sides. Yep, I heard. Bunch of sides. I need either another angle. I need an angle or another side, right? But what do we have going on in this one? That's that reflexive property we just introduced you to. That this ln is being shared. So I'm going to give it a triple tick marks to tell me, hey, it's definitely not the same as the other 2 that have been marked up, is it? So just kind of denote that it's not the same. So that ln is equal to ln. Again, that's that reflexive property being used right there. And I'm going to actually go ahead and state that off to the side. I should have stated up top. Again, that reflexive property is being stated as ln is congruent to itself. ln. That's what the reflexive property is stating. It can say it for an angle too. I could have had an angle marked up there. Angle A is equal to angle A. It's just equal to itself. And then give me the statement, guys. Give me the name of a triangle, because what did we just match it up to? What shortcut did we just now enable? Side, side, side. Just work. That is correct. Triangle, what? MLN, I think I heard, is going to go with triangle. M goes with what? B. L goes with, and this is the kind of tricky one. Just make sure, if I start off with going to L now, L is between 1 and 3. What's between 1 and 3? N is, right? So P, N, and then back to L. Okay. All right, coming back around. Letter D. On letter D, I jump to my 5 shortcuts. Anybody? What do we have possibly for that one? HL. When I look at HL, for me, one thing that jumps out to me is a right angle. Doesn't imply I'm using HL, but it brings that as one of my top of my list. Then I look at the hypotenuse. Got to have a leg, and where is my leg? There's that reflexive property being used again. Reflexive property is a common one used here. Okay, so that reflexive property is happening there with zy equal to itself, congruent to itself, zy. And that's it for the HL. You have a right triangle, you have a hypotenuse, you've got the leg, we're done with the HL. So that is enough to say we're congruent now. We've got 2 congruent triangles. And then name it out for me. What's the name of one of the triangles? XZY. Very nice. Okay. And if you name XZY, X is going to go with what? Yep, U, and Z is going to go to where? Y, I think, and then Y is going to come back to Z. Okay. Last one, my bow tie picture. There are certain things that usually go work together. Bow tie picture is going to come back around, and that's going to is going to use what? Before I say angle, side, I'm going to first mark up what? Vertical angles. I can't stress that to you enough that probably vertical angles are going to be used. There's probably a small 10% of the time you're not going to use vertical angles because there's maybe other things given to you. But in these types, probably going to use them. Vertical angles are happening. And then lastly, reading that carefully, the common mistake I hear students say is maybe ASA. But you got to pay attention to where that side is. Is that side between those 2 marked angles? It is not. That side is outside of those 2 angles. So as Eva suggested to us, this is read as angle, side. AAS. Okay? AAS. For it to be ASA, it would have had to be like that. And that's not what we have. Finish it off and name it out. Triangle, what do we got? RST is congruent to triangle what? What is this here?
I said U.
Is that a U right here?
I think.
Okay, we're going to go with that because it got cut off, obviously. So we'll call that a U. U, what did we just say? V and T. Okay.
Yeah.
Okay, we'll call it a U. That works for mine, Eva. Okay, let's go back to your notes real quick. I want to talk about one last thing now. After we got through all of that, go to page right here. So we have 5. And the ones, what page is this? 181. The last one I want to talk about, all right, is right here. Is this one right here. I always have some students also want to throw this one out here. Is the one that's angle, AAA, AAA. All right. Anybody have an idea of an angle, maybe counterexample of that? We've talked about some work with that throughout the school year. We've talked about it kind of recently too, with regular polygons. Angle is never going to work for us. Okay, they're not going to be congruent. With that, what we can have with angle, so A is never going to happen for us. This is not going to be a triangle congruence. What this is, I heard somebody just say it. Angle is not congruent. It's actually going to be called what we talked about second semester. This leads us into similarity. And what's similarity mean again? That's right. They are similar.
The same, but they're not the same size.
Same shape, different size. Right. That gets us into like I talked about the dilations, I think, a couple times, right? So we'll talk more about similarity second semester. And the easiest one to talk about that with is one of our triangles, our regular triangle. Our regular triangle, we said, is a case where we have all equal angles and we have also, say, all equal sides. Okay, all equal sides. Somebody give me a number. What was that? 30? Okay, that's quite the size there. Let's bring that down a bit. Let's just go 3. Okay. All right. That's fine. I wasn't expecting that large of a number, but we'll go with 3. That still works. So this is, we're going to go with base of 3, preimage of 3. Okay, but to be here, we've got equal angles, right? But here, I could do the exact same thing, where we've got this all going, and what we've done here is we've kept the same shape, right? But what have we done here? I enlarged it. Okay, we've kept the same shape, but we've enlarged it. So this is considered to be a dilation. It's not a congruence, is it? It's a similar figure. So on this, excuse me, on this one, we've enlarged this one, or if you were looking at from the right left, we reduced it. Okay. So here is an example where the angles are congruent, aren't they? Angles are congruent, but what do we do here? This is not a congruence then. So angle does not get that for us. Because even though angle still implies the size would be the same, it doesn't necessarily get us a congruent figure. Okay, so AA does not get us congruence; it gets us actually similarity, which that's a second semester thing. Okay, all right, that's where we'll pause things then for today. Tomorrow, if you are here.